10 views. It's ridiculous.
It's probably the most ever because you were in there. Thank you.
Who was giving it 10 views?
Who are you making the video of?
Just the general masses.
Dang it. Oh, there's just two.
Maybe you want to go back and review it.
Oh,
Okay.
wait, does that mean it's hard?
Generally, people find story problems difficult, and I don't disagree with them. So let's take a look at 4-9. And then, Bo, we may tap a couple of questions from you as a group or just individually. So, okay, area problems. Okay, so we're going to be working with mostly areas of rectangles. So 4-9 is area problems. And let's go ahead and talk about a rectangle. The dimensions of a rectangle we generally refer to as what? Length and width, or what's the other option? Base and height, right? So that's usually length and width, or you could say base and height, just so that we have some terminology correct. Okay, now when you have a circle, which I think there's one problem with a circle, possibly. I think you have one of those. So like a circle, anybody know the area formula for a circle? Area is equal to pi r squared. And sometimes what are we doing here?
I had to correct my test correction.
Oh. Yeah.
Do I not? What? I did my test correction wrong.
Oh. Go ahead, turn in. Perfect. There we go. Pi r squared. So with pi, sometimes they recommend using 22/7. Have you guys ever seen that?
Yeah.
That's just an approximation for pi. It is not actually pi. It's just an approximation. So sometimes in the problems they have you do that. Okay. And then r is your radius, which would be from here to like there. That's your radius. Okay. All right. So in area problems, we have this area of shaded regions. And so I'm going to do this area of shaded regions. And you don't have to follow this model, but if you have a rectangle that looks like this here, and then you have a rectangle that looks like this, and you have this shaded region like this, okay? If I want to find the area of the shaded region, there's a little like formula that I set up, and what we would do is if we just wanted to find this area along the outside, you would find the area subtotal. Area subtotal is made up of two things. It's made up of the area of the shaded plus the area of the unshaded. Okay? And we'll do some problems like this. So if you were trying to only find the area of the shaded region, you would actually need to find the total area minus the unshaded, and that would leave you with just that boundary along the outside. So we're going to do some problems that might entail that. So if you're like, oh, how do I find just this area around the outside? Because it's not just length times width, because it's this little strip. You would find the total area minus the unshaded area, and then that would give you what's left, which would be the shaded area. Okay, so we can set up problems like that. So let's go to our book on page 173, and go to problems number 1. Okay, so page 173, problems number 1. So not the oral exercises, go to the problems. Now, it says a rectangle is 3 times as long as it is wide. What kind of picture should I draw?
Rectangle.
A rectangle. Yeah, not a circle and not nothing. So draw a rectangle. Here we go. It is here, and then it is here, and here. So, We could, thank you, we could write length and we could write width, and that's true. Our goal though is to have a lot of variables or a few variables or one variable. One variable if possible. Okay, so let's look at the information. It says a rectangle is 3 times as long as it is wide. So we could write length and we could write width, right? But then we have 2 variables. So is there a way to write one of those variables in terms of the other? Yeah, Catherine.
For length, you could go 3W.
Okay, so for length, I guess I can leave L is equal to 3W because the length is 3 times the width. I like it. So now I have 3W for here and I have W for here, one variable being used. Okay, so in this it says if its length and width are both decreased by 2. So you're going to take your rectangle, you're going to make it bigger, you're going to make it smaller. Smaller. Decrease means smaller. So I'm going to rewrite the rectangle. It's going to be a little bit smaller. You don't have to do exact dimensions by 2 or something like that. It's going to be smaller. So we have a new rectangle. The new rectangle is decreased by, how much did they tell you? 2. So when it says decreased, are they dividing or are they subtracting? Subtracting. So instead of W for the width, what is it going to be? W minus 2. And then instead of the length being 3W, what is it going to be? 3W minus 2. So now I have 2 rectangles with all the information, at least for the dimensions given to us. The next part it says find, its area is decreased by 36 centimeters. So the area went from here to here, it got bigger or smaller? Smaller. So the area, I'm just going to put decreased by 36. So again, when something is decreased, that means subtraction. Okay? So now it says, find its original dimensions. So we want to find out what is the length and what is the width of the original rectangle. Now it says make a sketch as in oral exercises number 1 or number 2 or something. We've done a fine sketch, so we're good here. The oral exercises 1, it shows you a rectangle here, and then they decrease it like this, and they make a smaller one inside. That's fine to do as well, if that's helpful. I'm just drawing 2 separate rectangles. Okay. So let's think about area. Does the area of the big equal the area of the small? I'm going to write that. Does the area of the big equal the area of the small? True or false? False. False. We're back to our hand problem. Area of big, area of small. They don't equal each other, right? So not true, but is there something we can do to make them true? Yes. Okay, what do I need to do? Either bring big down or bring small up. It doesn't really matter. What do you want to do?
Bring small up.
Bring small up? Okay, bring the small one up. Let's look out for the little guy. What do we do? What do I do? Add? 36, because this one, right, it was decreased by 36. So if I add 36 to the small, then they would be equal. So if we want to make them equal, we need to add 36 to the small. All right. So now we're setting up an equation so that we can solve. So now we need to figure out what is the area of the big rectangle. Go back to your big rectangle. What's the area? We already discussed. Well, I didn't actually write the area formula up here. I meant to. What's the area of a rectangle? Base times height or length times width, depending on what verbiage we're using. All right, so in this case, what's the area of the big rectangle? It is the length times the width. Do I want to use L and W? No. What would I want to use? 3W and W. So the area of the big is going to be 3W times W, which I think I heard somebody simplify it, thumbs up, is equal to the area of the small. Well, the area of the small is length times width, which is going to be 3W minus 2 times W minus 2, and then squeeze this in here, plus the 36. Somebody had said over here the area of the big was 3W what? Squared, right? Because 3W times W is 3W squared. Have we been able to solve equations with a squared value in it? No. What do you fully expect your squared values to do? Cancel. So if I have a 3W squared over here, what should I end up with over here? 3W squared. In chapter 5, that won't be the case. We'll be able to solve for w squareds. Here, we don't know how to, so they should cancel. How would I go about simplifying this? Khalid?
Distributing.
Yeah, distributing. What do we call the distribution? Binomial times a binomial. What's our little acronym we've used? FOIL. Yeah, great, FOIL. I like distribution though because it's not always available to FOIL. So we go ahead and we distribute. So you would get 3w squared minus, right? That 3w goes into both. 6w minus 2w plus 4. I really wish I'd just written this on the other side. Plus the 36. Sorry about that. All right, on the right side, let's simplify that down. We're going to transition away from the bottom of the board here anyways. We're going to leave the 3w squared in play until we simplify. Negative 6w minus 2w. Sometimes we're struggling a little bit with that still, but what does that give us? Negative 8w. Good. If you're struggling with that, you're like, what? Why is it negative 8w? We got to go back and review from chapter 1, I believe, or chapter 2, actually. And then 4 and 36 gives you 40. All right, I'm going to transition this to the top. What would my check with your cheat mate and say, hey, what's our next step in solving this? Do a quick check with your support team around you. Ask them what your next step is, or you can tell them what the next step is and say, hey, are we going to multiply, divide, add, subtract? Just check with each other real quick. Give a quick little plan. Okay. That was a crisp high five. Okay, what's our general plan? Harrison, I heard you say something that sounded potentially correct.
Minus 3w squared on both sides.
Okay, why do people get uncomfortable with subtracting 3w squared from the left-hand side? JD?
Because there wouldn't be anything on it.
There's nothing there, right? And we're like, ah. Again, look at most of our wallets. Open it up.
Yes.
There's nothing there. So how many dollars do you have?
Negatives.
Negatives in your wallet? Wow. Wonder what that would look like. Yeah, it's all up there, clean. All right, when you open up the wallet, what do we have? How many dollars? Nothing. What is nothing called? Zero. Very good. So we get uncomfortable, but get used to lots of problems. You're going to get a 0. That's okay. Then you have negative 8w plus 40. Next step. What would our next step be to solve? Add the 8w to both sides. Okay. As this is a negative, so let's do the opposite. And we're going to add 8w to both sides. 8w is equal to 40. Very good. And then our next quantum leap is to divide. And what do we get? Divide both sides by 8, and you get w is equal to 5. Careful. Don't just stop there. I usually don't mark off for units. I probably should be a stickler, but at this point we're just trying to survive. So we'll take 5.
Just
Trying to survive. If you just put 5 and you move on, unfortunately you're going to lose a point. And you're like, oh, bummer. You were so close. What am I missing?
the area.
No. Read the question. What does the question ask for?
The length.
Original dimensions. Therefore, I need the length. So what is the length going to be on the original?
15.
15. Okay, because 3 times 5 is 15. 15 centimeters. So make sure you get a width and a length. Okay? All right. We're going to move forward to another problem. Yeah, Harrison, unless there's a question.
So what's the difference between this lesson and like the last lesson we did with problems like this?
Which one was that one? Like back in chapter 3 or something? Or?
Yeah, I don't remember. I was wondering if there's like a significant difference.
Probably in the other one, it was dealing with potentially perimeter. What's different here is when you're multiplying, you're getting a 3w squared, because chapter 4 deals with when we multiply variables together, we get like monomials together, we get something squared. And we also dealt with the FOIL method in chapter 4, so it's introducing FOIL method and squared values and solving equations.
Okay.
So that's my guess is comparing to the other ones, which might have been perimeter or something. And perimeter is that things multiply together, so you wouldn't end up with a squared value.
Yeah.
So it's introducing this concept of ending up with squared values and using our FOIL method. Okay, so let's go ahead and look at, I think we can try to squeeze in 2 more. We may not solve the whole thing, but we'll at least set it up, okay? And then you'll have that, because these are all homework problems for you. Let's look at number 5. Let's jump up to number 5. I think that will... So it says on number 5, a brick patio is twice as long as it is wide. Therefore, we're dealing with a circle, a trapezoid, a rectangle. What are we dealing with? A rectangle, you bet. So we go ahead, it says, hey, let's draw a quick picture just for that first statement. A brick patio is twice as long as it is wide. So we're going to, and then go ahead and label it. How many variables do you want to use? 1. So label it, check with your support team and say, hey, did you put L and W? And they're going to say, no, don't do that. It's 2 variables. We want 1 variable. So I'm going to drop this here. So it's twice as long as it is wide. Kind of similar to number 1 with that statement. All right, so you have your width and your length, okay? What did we say for width? What variable did we say for width? W. And then what variable did we say for length? 2W, because it's twice as long as it is wide. So L is equal to 2 W's. Then it says, a little bit different, a brick patio, oh no, we already read that. It is bordered on all sides by a garden 1.5 meters wide. So what we have is a border. I'll have to make it a little bit bigger. The border is on the outside here, right? And this is some sort of garden. So it'd be a nice like flower bed all around this brick patio, and you could step in and sit there and sip your coffee and look at all your flowers or something. So we have this flower bed on the outside. Now, do they tell you something about the dimensions of the flower bed? Read the problem. I think they do. What do they tell you? 1.5 meters wide. So that means, what's the distance from here to here? 1.5. What's the distance from here to here? Okay, it's not tricky, but what's the distance from here to here? 1.5. And what's the distance from here to here? 1.5.
That's crazy.
So now, can we write an expression for the whole, for the new width and the new length? Yes. You know, here we said it was decreased by 2, so we wrote, 3W minus 2, 3W minus 2. Here, our little rectangle is getting expanded or decreased? Expanded, okay? It's getting expanded. So this width was W. What's my new width?
1.5.
W plus?
3.
A lot of times we say 1.5 because that's what we see right here, width plus the 1.5. But remember, you have a 1.5 here and a 1.5 there. So what's the new width? 3. It's not just 1.5, it's going to be W plus 3. And then what's our new length going to be? It was 2W. Now what is it going to be?
2W plus 3.
2W plus 3. Okay, you see how this is lining up to be kind of a similar type of problem? I mean, we've got our binomial and our binomial, just like we had here and here, now we have here and here. All right, let's read then. It says, find the dimensions of the patio if the area of the garden is 54. So we are looking for this dimension right here. What they tell us is the area of the garden. What's the area of the garden? 54. Okay. So what that means is the strip all the way on the outside is 54. So we're going to shade, just for the visual sake, we're going to shade that. So now we're gonna backtrack over what I said earlier. If you want to find the area of a shaded region, isn't that lining up with what we're creating here? You will need to find the area of the shaded region. Let me erase this. I didn't write it out, I just verbalized it. Area of shaded region equals area total minus area unshaded. Right? I didn't write that out, we just talked about it. So if I want to find this, I just take the area of the unshaded to the other side. So it seems that that could work. Or the other way is to say the area of the unshaded is equal to area total minus area of the shaded. That's another one we could state. Is that the area of the unshaded is equal to the total area minus the area of the shaded region. So let's talk here. Let's talk about what is the area of the unshaded, of the patio in this case. What's the area of our patio? 2W times W. Sorry about it's all this shading and black marker everywhere, but hopefully we can see. Right? The area of this patio is 2W times W. What would the area total be of the entire thing? How would I write the area of the entire thing? It's not 54 because that's just the area of this.
2W times W plus 54.
2W,
Well, it's W plus
yes, that would be true. That is true. But what would be in terms of its dimension, length times width? So what's our length here? 2W plus 3 times W plus 3. Now, you're right, and we'll put that into our total equation. So if we want to write an equation to solve for something, because we haven't solved for anything, or we don't have an equation we can solve for, we know that the area of the patio doesn't equal the area of the total, and the area of the garden, we already know what the area of the garden is 54. They already told us that. So using these three pieces of information, here, here, and here, can I combine those into one equation? The answer is yes. That's what we want to do. Take a second here, combine those into this, this, and this need to end up in an equation. Okay, so check with your support team and see if you can come up with these three pieces of information into one equation that we're going to solve for. Very similar to over here, we're just writing it a little bit different. If you want to think about the shaded and unshaded formula, you could do that. If you want to think about having one small area added to a small area equaling a big area, that also works. Do something like that. So all three pieces of information, here, here, and here, need to be combined into one equation. So check with your support team, set it up, and then say, hey, I have this, what do you have? No? Okay. JV, you want to talk to him? No. Okay. The battle lines have been drawn. All right. Are we getting something? Jackson, you got something for us?
Not yet.
Oh, okay. It looked like you did.
No, I'm just looking at it.
You're just brainstorming? Okay. There's multiple ways you could set it up too. Kind of like here, there's three different equations I wrote from this idea of shaded, not shaded. There's three different ways you could write it.
Do you want us to solve it? Do you just want?
No, you could, but let's go. Did you come up with something, Harrison?
I think so.
Okay, let's see what you put and see if we can make sense of it.
Okay, so I put 54 equals.
Okay, so you're saying the area of the garden, so the shaded area equals
2w plus 3, like in parentheses.
2w plus 3.
And then w plus 3.
So you're saying the area of the shaded region is equal to the total area, the full area.
And then plus 2w squared.
I wouldn't go with plus.
Minus.
I would go with minus 2w squared, which is this one right here. So what you're saying is the big area, the total area minus this little area would leave you the outside area. Perfect. Yep, that works. Did somebody else set it up different? Okay, you definitely could if you wanted to say the big area minus the inside area. That would leave us with that. Oh, we already did that. The big area minus the shaded area would leave us with that area. Something like that would work. Okay, here we have a 2w squared. What do we fully expect to happen? It should cancel. Okay? Will it cancel when we FOIL?
Yep.
Yep, it absolutely should. So 54 equals, and we FOIL that out, right? Foiling, just like Caleb reminded us, is just a glorified form of distribution. So we take our 2w and you distribute it in. So you get 2w squared plus 6w plus 3w plus 9. Hopefully you're getting comfortable with that foiling method or the distribution method and can pump out those numbers with at least, maybe not with ease, but with understanding. And then, sure enough, what happens to our 2w squareds? They cancel, and you got 54 is equal to 9w plus 9. Do not, again, the errors start occurring. 18w. Nope. Not like terms. So how do we solve?
Minus 9.
Subtract the 9 from both sides. Alright? 54 minus 9?
45.
45. 45 equals 9w. And then
5.
w equals 5. Now where we jump ahead and say w equals 5, where did I get w equals 5? Or where did you get w equals 5? Divided by 9. Yep, and this is in meters. So w is equal to 5 meters. What does the question ask for?
What are the dimensions?
Dimensions of the patio, right? Perfect. So we're going with this patio. So we know w is 5. Perfect. What's the length? 10. Where do you get 10 from? 2 times 5.
Light work.
Okay, 10 meters. All right, so we are almost out of time. This is not due tomorrow. This will be due on Thursday. So what I'm leaning towards is, what is tomorrow? Wednesday. We'll probably talk about 4:10, but then I'm leaning towards doing maybe a couple days of review on Thursday and then Monday. And actually what I'm leaning towards is 4:10. No, not 4:10. 4:08 is due tomorrow. I know Bo had contacted me about a couple questions. We haven't had a chance to look at them yet. We can work at the start of lunch for a minute or two, real quick. What if we make 4:08? Some of you may be done with 4:08. 2 thumbs up. It's awesome. Let's make 4:08 due on Thursday.
Oh my god.
Did you get it done? That's awesome.
Yay. Me and Jack
So-
and I are
That's great. So
Wait, so 4-9 due next week then?
let's aim for 4:09 to be due on Thursday as well. But we'll reevaluate tomorrow. So okay. We're kind of like no.